Article 210.52 defines wall space as the vertical space along the side of the room that is above the floor and below the ceiling. It does not specify a height requirement. However, the exception in Article 210.52 states that fixed room dividers, such as railings, can be considered wall space for the purpose of outlet spacing. The 9-inch drop in the floor can be considered a fixed room divider, similar to a railing. Therefore, the space afforded by the drop could be considered wall space and would require outlets to be installed every 12 feet. While the 9-inch drop may not be a significant obstacle for furniture placement, it could be inconvenient to plug in a lamp or other device in that area if no outlets are provided. By requiring outlets in the sunken portion, it ensures that there is a convenient and safe way to power electronic devices. It also aligns with the intent of Article 210.52, which is to provide adequate electrical access throughout the habitable space. While co-workers may view this interpretation as picky, the National Electrical Code does provide a reasonable basis for requiring outlets in the sunken portion of the living room. It is ultimately up to the authority having jurisdiction to determine whether the 9-inch drop meets the definition of a fixed room divider. However, based on the National Electrical Code language and the practical considerations, it is a valid interpretation to consider the sunken portion as wall space requiring outlets. The main point of contention revolves around interpreting Article 210.52 of the National Electrical Code, which addresses the placement of receptacle outlets in dwelling units. The specific scenario involves a living room that is sunken approximately 9 inches below the level of the adjacent kitchen and dining areas, all within one large open room. The question is whether this 9-inch drop should be considered wall space, thereby requiring receptacle outlets to be installed along it every 12 feet according to the code. Article 210.52 defines wall space as the vertical space along the wall above the floor and below the ceiling. This definition is seemingly straightforward, but the code does not explicitly define a minimum height for what constitutes wall space. This lack of a specific height requirement leads to the core of the disagreement. The argument for treating the 9-inch drop as wall space hinges on the exception outlined in Article 210.52, which addresses fixed room dividers such as freestanding bar-type counters or railings. The argument here is that the 9-inch drop acts as a fixed room divider, albeit a very short one, and therefore should be subject to the same receptacle outlet spacing requirements as a traditional wall. The justification for this interpretation is that even though the 9-inch drop is not a substantial barrier, it can still serve as a place where occupants might place furniture, such as a couch with a lamp. If a lamp is placed there, it would need a receptacle outlet to plug into, and the absence of one would be inconvenient and potentially unsafe, leading to the use of extension cords or other unsafe practices. The counter-argument, presumably held by the co-workers, is that the 9-inch drop is too insignificant to be considered wall space. They might argue that it doesn't function as a true room divider in the way that a bar or railing does, and that it's unlikely that occupants would regularly place furniture against it. They may also point to the fact that they have wired this particular model of home dozens of times without ever being cited for a violation, suggesting that the local authority having jurisdiction does not typically interpret the code in this way. Ultimately, the decision of whether or not to require receptacle outlets along the 9-inch drop rests with the authority having jurisdiction. They are the final arbiters of code interpretation and enforcement. However, even in the absence of a clear-cut code requirement, it's important to consider the intent of the code. Article 210.52 is intended to ensure that occupants have convenient access to receptacle outlets throughout their homes, reducing the need for extension cords and promoting electrical safety. Given this intent, there is a reasonable argument to be made for requiring receptacle outlets along the 9-inch drop. While it may seem like a minor detail, it can improve the usability and safety of the space. It's also worth considering the potential for future changes in occupancy or use of this space. What might seem unlikely today could become commonplace tomorrow. Installing receptacle outlets during the initial construction is far easier and less expensive than retrofitting them later on. The practical considerations also weigh in favor of installing the receptacle outlets. The cost of adding a few receptacle outlets during construction is relatively small, while the benefit of having them available can be significant. It provides flexibility and convenience for the occupants, and it eliminates the potential for unsafe wiring practices. The code provides a minimum standard for electrical safety. Electrical inspectors and installers may choose to exceed these minimums in order to improve the safety and usability of the electrical system. In conclusion, while the National Electrical Code does not explicitly require receptacle outlets along a 9-inch drop in a living room floor, there is a reasonable basis for interpreting the code in that way. The 9-inch drop can be considered a fixed room divider, and requiring receptacle outlets aligns with the intent of Article 210.52 to provide convenient access to electrical power throughout the home. The decision ultimately rests with the authority having jurisdiction, but electrical inspectors and installers should consider the practical considerations and the potential benefits of exceeding the minimum code requirements. Here are a few additional points to consider. 1. The specific wording of the local electrical code may vary slightly from the National Electrical Code. It's important to consult the local code to ensure compliance. 2. It may be possible to obtain a formal interpretation from the authority having jurisdiction. This can provide clarity and certainty, and it can protect from potential violations. 3. It's always a good idea to document the reasoning behind any code interpretations. This can be helpful in the event of a dispute or audit. 4. The long-term benefits of installing the outlets outweigh the cost. It ensures better access for any device that would need to be plugged in. 5. Make sure that the receptacle is installed at the correct height, is tamper-resistant, and is correctly grounded. 6. The receptacle faceplate should be properly installed to cover any gaps that would expose the electrical terminals. 7. Ensure any wiring is properly rated, sized appropriately for the breaker and receptacle, and installed per manufacturer recommendations. The code requirements are intended to keep the users safe from electrical hazards. This includes shocks, electrocution, and fires. Staying up to date with the changes to the code will help provide a safe install. First, review the blueprints to see the layout of the room and where the receptacles are located. Second, check the specifications to ensure that the correct materials and methods are being used. Third, conduct a visual inspection to identify any obvious defects or code violations. Fourth, perform electrical tests to verify the wiring, grounding, and bonding. Fifth, document any findings and recommendations in a written report. The receptacles must be accessible. This means that they should not be blocked by furniture or other obstructions. The receptacles should be located where they can be easily reached and used. In addition, the receptacles should be installed in a way that minimizes the risk of damage. For example, they should not be placed in areas where they are likely to be bumped or stepped on. Finally, the receptacles should be properly labeled to indicate their voltage and amperage. This will help to prevent accidental overloads. When selecting receptacles, it is important to choose the right type for the application. There are many different types of receptacles available, each with its own set of features and benefits. Some of the most common types of receptacles include standard duplex receptacles, ground fault circuit interrupter receptacles, and arc fault circuit interrupter receptacles. Standard duplex receptacles are the most basic type of receptacle. They have 2 outlets and are typically used for general-purpose applications. Ground fault circuit interrupter receptacles are designed to protect people from electrical shock. They have a built-in sensor that detects ground faults and interrupts the circuit if a fault is detected. Arc fault circuit interrupter receptacles are designed to protect against electrical fires. They have a built-in sensor that detects arc faults and interrupts the circuit if arc is detected. In general, Article 210.52 of the National Electrical Code focuses on ensuring adequate placement of electrical receptacles in dwelling units to promote convenience and reduce the use of extension cords. Let's break down some key aspects of this article. Firstly, wall space is defined as any wall space 2 feet or more in width. This means that any section of wall that is at least 2 feet wide must be considered when determining receptacle placement. Secondly, receptacles must be installed so that no point along the wall line is more than 6 feet from a receptacle. This effectively means that receptacles should be spaced no more than 12 feet apart. Thirdly, in kitchen and dining areas, receptacle placement has specific requirements. Countertop spaces 12 inches or wider must have receptacles. No point along the countertop should be more than 24 inches from a receptacle. Fourthly, receptacles should be located within 36 inches of any basin in bathrooms. This is for convenience when using appliances like hair dryers or electric razors. Fifthly, outdoor receptacles are required for dwelling units. At least one receptacle must be accessible from the outside of the dwelling. Sixthly, hallway receptacles are required in hallways that are 10 feet or more in length. This ensures that there are accessible outlets in longer hallways. Seventhly, any isolated wall space that is at least 2 feet wide should have a receptacle. This includes spaces like peninsulas or other areas that are separated from the main wall. Eighthly, receptacles should not be located directly above baseboard heaters. This is to prevent fire hazards and damage to cords. Ninthly, all 125-volt, 15 and 20 amp receptacles in dwelling units must be tamper-resistant. This is a safety measure to prevent children from inserting objects into the receptacles. Tenthly, ground fault circuit interrupter protection is required for receptacles in certain locations such as bathrooms, kitchens, and outdoor areas. This is to protect against electrical shock in wet or damp environments. When applying these rules, it's important to measure wall spaces accurately and consider any obstructions that might affect receptacle placement. The goal is to provide convenient access to electrical power while maintaining safety. Consulting with a qualified electrician can help ensure compliance with these requirements. Remember that local codes may have additional requirements or variations on the National Electrical Code, so it's always best to check with local authorities.